Okay, now just to complete the section on electromagnetics, I'm going to do a couple of circuits, and essentially in a circuit there's a recipe to solving them, okay? And that entails just knowing, obviously you know how to combine resistors in parallel and resistors in series and so forth, besides you're given a formula for it. The only other formula you need to know essentially is going to be that V is equal to IR, correct? That's really all we need to know, okay? But just before we move on, please note that the EMF of the battery that we're given, if they give us the voltage of the battery or the EMF of the battery, that there, let's say it's 12 volts, it means that the voltage drop across all the resistors in the circuit must equal that battery, because it's the only source of EMF in the circuit, isn't it? There is no other source of EMF in the circuit, right? So let's have a look. Here we've been given a, okay, just let me erase that so that I can start with a clean slate. Let's have a look. They say we've got a circuit here, and there's our battery over there like so, and they give us down here, and there's an ammeter there going across. There's over here an unknown resistor of R, and we now say, okay, then we split over here into two other resistors. Those are obviously now in parallel, are they not? Okay, we move that, and this comes down over here like so. Now we say, right, they tell us that this is a 20 ohm resistor, this is a 40 ohm resistor over here. R is unknown, we don't know it, but they tell us that we've got 3 amps flowing, and the EMF of the voltage of the battery we don't know. Okay? Right, now the first thing you always do in any of these problems, put in the current I, okay? And take it as the conventional current from positive to negative. So here we go. I. Now you can see I've got I here, right? But now we're going to have to split I into I1 and I2 over there. And when we come out over here, it becomes I again, right? So now let us solve the circuit, okay? In other words, they want to know the current through the 20 ohm, blah, de, blah, de, blah, okay? Let us first of all say, right, we've got the current so we can see it splits over there, okay? We can combine these two resistors over here to work out an effective resistance, can't we? So let us do that, okay? All right? P.S. Always start where you've got the most information, okay? And yes, there we could combine those, and we could do that. And it doesn't matter if you do that now or not. But if you look, what do we know at this component over here? We know I is 3, and we know, okay, and they tell us that V, a voltmeter reading over there, was equal to 24 volts, okay? What does that mean? It means that at this one here, we've got 2 out of 3. We've got V and we've got I, okay? Therefore, for that component there, we would say V is equal to IR. So 24 is going to be equal to 3 times R. Therefore, R is going to be equal to 8 ohms. And you can put it in straight away. Once you have put in, it's the same as a mechanics problem. Once you've found something, excuse me, put it back in onto your circuit, right? Same with your drawings of in the mechanics side, in Newton's laws. Put in as you find stuff, and then because you're going to be using it from the next part onwards. So we say here, okay, therefore now over here I know that this is also going to be 3 amps because it's the current as it moves out of the two resistors in parallel. Let's now put these resistors in. Let's work out the effective resistor. Now you know that the effective resistor, okay, is going to be, I call it with my students, the ghost resistor, or whatever you want to call it. But that resistor there, R, right, effective, is going to be 1 over R effective is going to be 1 over 20 plus 1 over 40, which is going to be equal to 43 over 40. Now don't forget, therefore R effective is going to be 40 divided by 3, okay, ohms. Please don't forget that last flip at the end, because what happens is that is unfortunately where a lot of people, because I know you guys are in a hurry and time is of the essence in it, but that little flip, okay, so many students forget to do that. So just as you're going through and as you're doing some prep work for this, just make sure that you say to yourself, must remember to flip it, okay? All right, so therefore we know that's a 40 over 3 ohm resistor, and we can put it in the same green color, 40 over 3. Now, there's a couple of ways that we can progress now. We can say, all right, let's just go back and say, well, we know that that's 24 volts. Now, the key is that the voltage across here and this side of the parallel pair, it's the same voltage, okay? Because remember, resistors in series split the voltage. Resistors in parallel, they have the same voltage, they split the current. Hence, voltage splitting circuits, current splitting circuits. Okay, so what you got to do here is say, well, how do I work out V? Well, there's a couple of ways you can go, but essentially we can say, hang on, let's use this ghost resistor of ours. We know that if we take those two out and replace it with that, we have the same effect on the circuit, which means the current I is now only going through that resistor, isn't it? Which means that the voltage there, V, must be equal to I times R, which is going to be equal to 3 times 40 over 3, which is going to be equal to 40 volts. So we can immediately say that's 40 volts, and that's equal to 40 volts over there, isn't it? Okay, just by using that resistor over there. The other way we could do it is we could say, hold on, let us work out the total resistance of the circuit. Because in any circuit, what we're trying to do is to get it down to one EMF source, voltage, one resistor, and hence we can work out, because we've got 3, we can work out the one we don't know. Let's have a look at this. And we say, all right, let's combine those. So therefore, R of the circuit, okay, is going to be equal to 40 over 3 plus the 8, correct? Plus 40 over 3. That is going to be 21.33 recurring ohms. Now we've got that resistor would be, if we took the 8 away and the 40 over 3, that one, and put 1 in, it would be 21.33 ohms. Okay? So what do we now do? We say that V is equal to IR. I is 3, right, amps in the circuit, remember? That was the current flowing through the circuit, times 21.33. That is going to be equal to, and if you work it out, comes to 64 volts, okay? Okay, so that's the EMF there. I worked that out as 40. Now, let's go back and say, right, if that's 40 volts across the two parallels, and it's 24 across the other, I must add them to be equal to 64 volts, right? In other words, what have I just done? I've added the known voltage here plus that one there to get us a 64 volts, right? And I've checked it out by doing it this way as well, and I get the same voltage, okay? Then we say, right, let us work out what the currents are in all of this then, okay? Let's say, okay, they might say to you, for example, what is the power dissipated in the 40 ohm or the 20 ohm resistor or whatever the case might be? Whatever, you still need to get the current. Let's work out what the current is. Well, now we go to each individual component on its own, and we say, let's look at U. I know the voltage across U is 40, and I know that your R is 40. Therefore, I2, V equals IR. Voltage is 40. I'm working out here, this is the I2. Okay, this is what we're working out here. 40 is equal to I2 times 40 therefore I2 is going to be equal to 1 amp, right? So I go back and I put you in as 1 amp. Straight away I can see that I1 is going to be equal to 2 amps. You can check it out. It's 40 divided by 20, which is 2 amps. Therefore we've got that. Now if we say what is the power dissipated in the resistor, you can say power is VI, which is going to be V, is going to be 40 volts times 2 amps, for example, 40 volts times 2 amps, which is going to be 80 watts. So in there is 80 watts, right? Now, please be, in the next example, okay, I'm actually going to do one using power, but please be aware that at any point they could start with resistors or power given or whatever. You just write down what you know and look at each component in turn and ask yourself, what can I work out with that? Do I know V, I, and R? And if you know 2 of the 3, immediately work out the third. Okay? And that's how you solve a circuit. It doesn't matter how complicated it is. I mean, you're only dealing with one source of EMF in the circuits that you do, so that makes life a lot easier for sure. Okay. Now let's have a look here and say, all right then. Okay. Here's one. We've got a voltage of 12 volts. Okay. Like this. So we say, all right. Da-da, da-da. We have got a 12 volt battery, and we say, right. Then they once again over here, we've got an unknown resistor. Okay. So we just call it R, shall we? And coming down over here, we've got, and this is a favorite one, 2 light bulbs over there, and we're going this way. Okay, so we've got that circuit. Now it doesn't matter if I drew the circuit down there, I've still got the 2 in parallel. Okay, and they say to us that each of those is a 6 volt and a 2 watt. 6 volt and a 2 watt. What are we saying there? We're actually saying that those there operate, okay, you will dissipate 2 watts with a 6 volt across there. So first of all, what do? Recipe says put in current. So we put in current, I. I goes through this resistor. I is going to split into I1 and to I2 over there. So the last bit of information we can put in, they've told us that it's a 12 volt battery. Okay? Okay, so what does that say now? Let's go where we've got the most information. Generally speaking, an appliance is rated at certain power with a certain voltage. If you look at light bulbs, if you look at microwaves, kettles, whatever, you'll see 230, 240 volts, and you've got 1.5 kilowatts, 1500 watts of power. So over here, we immediately, the moment you see power, right, you say to yourself, power is equal to VI. Or, okay, the others, which is I squared R or V squared over R, each one of those, right, the formula. But those you're given anyway. Okay, so we say, okay, there. Now, what is the next step? The next step is to say, okay, in this case here, they have said that the circuit, they are operating there, and they have asked us, what is the value of that resistor there? Okay, what is the value of that resistor that needs to be put in that makes these operate at their peak operating condition, which means the 2 watts. So I can say that therefore 2 is equal to VI. But hello, they've told us what V must be in order for that to work. So therefore 2 must be equal to 6I. So I coming through there is going to be equal to 1/3 of an amp, isn't it? So let's go back and put it into our drawing. And that's the same. If it wasn't the same, you do it the same way. You'd basically just use your use the watts over there. The voltage, however, would have to be the same because they're in parallel, which means the voltage across there must equal the voltage across there. So that's going to be equal to also 1/3 of an amp, which means I can now backstep and say that my current over here is going to be equal to 2/3 of an amp. It's that one plus that one, isn't it? So the current coming through here, I, is going to be 2/3 of an amp. Okay? Now, let's look, what do we know? We want R. Do we know V? So let's look at this component here. Okay, let me just change color. Let's look, I is equal to 2/3 of an amp. R is what we're being asked for. And V, we don't know. Can we work out V? Well, just let's have a look. V across here is 6 volts, right? Those are in parallel. V across there must be 6 volts as well. Because we have set it to operate at 6 volts and 2 watts. That's what we're doing. So this R is our control resistor to ensure that we get that. So what we do, we know that if that's 6 volts, then what must the voltage across here be? Remember what I said about the EMF of the battery or the power source must be equal to the voltage drops across all of the resistors. Therefore, 12 minus 6, that's a 6 volt on that side as well. Okay? Therefore, 6 volts over there, which means I now know that voltage here is 6 volts. Therefore, R in this circuit is going to be equal to, from V equals I. R is going to be equal to V over I, and V is 6 volts, I is 2/3, and if you work that out, you get to a 9 ohm resistor. All right? And let's work out what the power dissipated in that is, shall we? The power dissipated in that resistor is going to be, power is VI in here, so it's going to be equal to 6 times 2/3, right? Which is going to be, 12 over 3 is going to be 4 watts. Okay? So, when we've got power, you can immediately go to it, all right, as long as you've got the rating. They could, for example, give you the power and a current. It's not done usually, but they could do so. So how do we solve a circuit? Well, first of all, what's the recipe? Is if the circuit's not drawn for you nicely at a scale, just a quick draw. If it's on your sheet and been drawn at a nice scale, put in what's given. Make sure you read the blurb, okay, on the side, and then put in what you've been given, so all the bases are covered. Then you put in your current, making sure you show it goes, and where it splits, do I1, I2, I3, whatever the case might be. Then you look for any component where you've got 2 out of the 3. And that's where you start the process of solving it. Okay? If, for example, you've got 2 resistors in parallel, you can combine them to form the, what I call the ghost resistor, okay? The effective one. And then you can move from there. And remember, you can use that effective resistor to work out either a current if you know a voltage, or a voltage if you know a current. Then you'd move along and you'd say, right, at any point, all the voltages across all the resistors must add up to the EMF of the battery. Okay? That's the fundamental principle of how to deal with a circuit. You have to go to where you're given the most information.